All right, so we're going to insert drawing here. Okay, and we can change this to scribble. Okay, so we can build this. We can go, all right, we're going to go, for this one, we're going to go for 2. So we said the other option from part A was just we're going to go for 1. This one, we're going to go for 2. So if we go for 2, we can be successful, or we can fail on the 2-point conversion. All right, and then after that, it'll break apart and we could still win or lose whether we are successful or failing on this, this go for 2, okay? And in fact, it said that if we are successful, then it's a 0.88 probability that we win. If we fail, it's still a 0.77 probability that we win. And they said use P as our probability of success on going for it. Okay, so then that gives us 3 of those branches. Now every branch split needs to add up to 1, so I can always do 1 minus the other branch. So for example, up here next to the 0.88, I can do 1 minus 0.88 gives me 0.12 right there. Down here, 1 minus 0.77 gives me 0.23. And then over here, 1 minus p would just give me 1 minus p. All right, so then I would multiply along the branches to fill out these 4 spots. Okay, so for the first one, p times 0.88, we're just going to call it 0.88p. P times 0.12, we're just going to call it 0.12p. Okay, and then for this one is a little trickier. We need to think of this as 1 minus p right there. So then when we multiply the 0.77, I have to multiply it by both of those things. So 0.77 times 1 is just 0.77. And then 0.77 times negative p is minus 0.77p. Okay, so then I need to do the same thing here with a 0.23. So 0.23 times 1 is just 0.23. And minus 0.23 times negative p is 0.23p. And then we can, oops. All right, so then we can close that out and it should pop up, there we go, on my Google Sheet here, okay? All right, next question, express the probability of the Saints winning if they go for 2. So for that, I'm gonna add up my win boxes. So I have a 0.88p is in the win box plus the 0.77 minus 0.77p is also in the win box because even though we failed on the 2-point conversion, we still win. Okay, so if I combine like terms there, I get 0.88 minus 0.77p is going to give me 0.11p plus 0.77. That 0.77 in the middle has nobody to combine with. And that's going to be our answer for part C. Okay, next up, for what values of p would it be worthwhile to go for 2 to attempt the 2-point conversion? So we're going to take our answer from part C, 0.11p plus 0.77. And then we're always going to want that to be greater than something. And it's going to be greater than our answer to part A, which is the 0.78 up here that we said we didn't use. That was the probability of making it if we go for 1. Oh, I deleted that. It's the probability of winning if we kick extra point going for 1. So as opposed to the probability tree is going for 2, this one's going for 1. So we need to compare the going for 2 from the probability tree to 0.78, which is our probability of going for 1. All right, I think I can solve this just typing it out. So I'm just going to subtract 0.77 from each side. It's going to cancel out the 0.77 on the left side, giving me 0.11p is greater than, and then I have to do the actual subtraction here, 0.01. All right, so now I need to divide both sides by 0.11. I don't know how to do that. So that'll just become p on the right side, greater than, and then I'll do my calculator, 0.01 divided by 0.11. And it is 0.091 about, okay? So to interpret that as a sentence, he should go for 2 if the probability of success is 9.1% or more. All right, so that's just saying if his initial probability right here is more than 9.1%, you should go for it. So if it's 10%, 20%, 30%, you should go for it. If it's less than that, or if it's less than that, then he should not.